All right, this is going to be objective 34. We are going to solve, we're going to look at, basically we're going to put it all together. We're going to look at logarithmic equations, we're going to solve exponential equations, and look at different ways. And there will be multiple ways to do this, okay? Certain ones you can only solve certain ways, but a lot of them there's going to be, one way to do it and then there's another way to do it, okay? All right, so this will be example 1. Now, in particular, if I gave this to you on the test next week, there is another way that you would already know how to solve it. Anybody want to tell me how? Logs, okay, so how could I change this into a log? It'd be log. The log base 2 of 7 is equal to x. And so, you could, in your calculator, use your math alpha math button and put in the log base 2 of 7, and that would give you, and let's round our final answers. Let's go 5 decimal places today. So it would be 2.80735. Yes? All right, that's option A, and that's fine. There is another way to do it because, see, old calculators didn't have this fancy-dancy log base button. And so there's another way to do it. And you need to know this other way because not every single one is going to work for you to just change it to a log. You with me on this? So, generally, we're going to use logs for this, okay? What you do to one side, you must do to the other, okay? So what we're going to do is we're going to take the log on either side, okay? And we're going to use our property. We need to get this x. We can't solve for that x while he's up as an exponent. We need to get him down. What does our law that we learned yesterday say we can do with the exponent? We can throw it in front of the log. So we can throw this in front and say, and take the log of 2. You with me? But if I take the log on this side, then I'm going to have to make this the log of 7. Okay? You with me so far? Now my question, this is x times the log of 2. So how would I solve for x? You could divide by log of 2. What base is this, by the way? Base 10. Okay. So, and those would cancel. And in your calculator, you could put in the log of 7, and you could actually use your just plain log key because it's base 10. If you wanted to use your math alpha math button and use log base, you're just going to put in a base of 10, okay? And divide it by the log of 2. What do you get? 2.8073. I'm not going to tell you how to solve it. You're just going to solve it, so either way is acceptable. So, if you want to use what we used the other day, that's probably the easiest thing to do, to be honest with you, is to change it to a log and just put it into math alpha math, okay? But there will be other equations where you will need to use this skill, where you take an log on each side or whether you take an ln on each side. When would I take an ln? A natural log? When we're using e. But I was using a base of 2, so that's why I chose to use a log. It actually technically, if you made this the ln of 2, like ln of 7 divided by the ln of 2, it's still going to work out. But just properly, generally when it gives me a base of a number or a variable, I use a log. If it gives me a base of e, I use a ln. Yes. So if this were e to the x, I would do an ln on both sides. Okay. Any questions on how I used my property and got the x down in front? Yeah. Okay, so in this case, this one, you could use your old way. So option 1, the old way is the log base 3 of 7 is equal to x plus 2. Correct? And so you could put in math alpha math, and you could put in the log base 3 of 7 and hit enter. And so you're going to get, and don't round this. Why do we not want to round this? Because we are in the, we're in the middle of a problem. 1.7712437749 equals x plus 2. And then how do I solve for x? I'm just going to take this 2 and subtract it over, and I'm going to minus 2. So x, when I minus 2, x is going to equal negative, and here we can now round, because this is our final answer, negative 0.22876 if you round it. Okay. Let's do this one, though. Let's do this one the new way. Okay. So, and we're going to take a log on both sides. Okay, so if I take a log on this side, what am I going to do with the exponent? I can't solve for x while he's stuck up there. Like, I feel like in my mind, I imagine him up in the sky and I can't get to him. So I need to pull him down so that I can work with him. So how do I pull the exponent down? I'm going to throw him in the front. So this is going to be the x plus 2 times the log of 3. And if I take a log on this side, then I need to take the log of 7 on that side. So my question is, these are being multiplied, so how would I get rid of the log of 3? I'm going to divide by the log of 3 on both sides. Those will cancel, and x plus 2 is equal to, you're going to have to figure this out as a decimal first, so this would be the log of 7 divided by the log of 3, and you get that decimal over there, 1.7712437749, and then you're going to move the 2 over and subtract 2, so x would equal negative 0.22876, which is the same thing. Any questions on that? Everybody's good? Okay. So, what's different about this one? It's got an e, so we know instead of a log, we're going to take a ln. Okay? And you could take a log base e of e. That would be fine, but just properly we don't do log base e of e. We just say ln of e. Okay? But before we do that, you need to isolate it. Meaning, what do I need to get rid of? How do I get rid of the 8 first? So we're going to divide by 8 first. You got to isolate it first. So this will become e to the 2x is equal to 20 divided by 8 is 5 over 2, or you could say 2.5. That's fine. And then, how are we going to get rid of e? We're going to take the ln, and what do I need to do with the 2x? I'm going to move him in the front, so 2x times the ln of e. And if I take the ln on this side, what do I need to do on the other side? I need to take the natural log on that side. Okay? What do we know about ln and e? They cancel out, and so you get 2x equals the ln of 2.5. So when you figure that out, you can use your natural log button, ln of 2.5. And then, what do you need to do to that decimal? We're just going to divide it by 2. So x is going to be equal to, rounded to the nearest 0.4585 if you round it. Okay. Now, what would be the other way to do this problem? You would still have to if you're going to take it to a log, you with me on this? You would still have to isolate it first. So you would take it from here. So how could you take it and do it the other way? The log base e, I'm going to do log base e so that you understand this. This is the base of what? 2.5, and that's equal to 2x. And so you could put that in your calculator. Does that make sense? Or you could just say the ln of 2.5. Okay, but math alpha math, log base e of 2.5. And so in this case, I almost think this way was easier than doing all of this. And you get 0.97, which is that same decimal, or 0.91629, blah, 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 blah. You divide it by 2, and you end up with this. Okay? Any questions on that? Say that one more time. This right here. We learned that this the other day in our properties. We learned that the ln of e cancels because technically that's the log base e of e, and that's one of your properties, e to the first. We know that those cancel out and you get 1. Does that make sense? And that's the same thing. ln of e, anytime you see ln of e, they cancel based on our properties that we learned the other day. It equals 1. And 1 times 2x would just be 2x. Any questions? Okay. Do you want to attempt this one on your own? Try it. Try it. All right. So in this one, like you could do the log base e of 4, get a decimal is equal to that exponent, 3 minus 2x. Anybody try it that way? Did anybody do it that way? Or did y'all do it the new way for today? Okay. I like the new way for today too. I think once you get used to it, I think you're going to like it. Okay? So we know to get rid of the e, we need to do what to both sides? We need to take the natural log. We need to take the ln. Okay? And I need to get this exponent down on a level that we can work with. So how do I get him down? I need to put him down in front. So this is going to become 3 minus 2x times the ln of e. And if I take the ln on this side, then I've got to take the ln on that side. So far, so good. All right. What happens to the ln of e, Seth? They cancel out. Very good. Okay. So then we get 3 minus 2x is equal to, and I'm going to put this ln of 4 in my calculator, and I'm going to get a big whopping decimal. So the ln of 4. And that's going to give me 1.386294361. So far, so good. Okay. Doesn't matter. What do y'all want to move? What do you want to move, Gonzalo? The 3. Okay. So when the 3 comes over, it needs to subtract. So I'm just going to put in minus 3 in my calculator. And so I'm left here with negative 2x. So this is negative 1.61370563 It's going to be a lot of decimals today, by the way, if you hadn't figured that out. And then how do I get x by itself? I'm going to divide by negative 2. And so I'm just going to take this and divide it by negative 2. And x is equal to 0.80685. My question is do you know where you went wrong? Yes? Any questions about that? All right, let's keep on going then. All right. So this this one, I'm giving it to you, the first four, each one of these are different, which is why there's 10 examples today, which is why I'm giving you kind of like one of every type. Okay, what's different about this one? Well, the other ones I gave it to you in exponential form, and we used logs. Okay, so here I'm actually giving you a logarithmic equation. Now we learned last week, if I give you a log on this side and a log on that side and the bases match, what can you do with the log and the bases? They cancel out, and then you can just set each part equal to each other and solve. Okay, here I would recommend, should we try? Let's go back to exponential form. Okay, so how would I take this back to exponential form? 2 to the 5th is equal to x plus 2. And I'd say that's going to be a good way. What is 2 to the 5th? 32. Very good. And then what should I do? I need to minus this over, and so x is equal to 30. So some of these are going to be really easy. I'm giving you a variety, like you just need to try it out. Try to go from exponential to log, try to go from log to exponential. Or if it's given to you in exponential form, generally to get rid of things we do the opposite. So the opposite of exponential would be to take a log on both sides. What you do to one side, you do to the other, and then you solve in that way. Okay? You just keep fiddling with it and going back and forth from exponential to log, log to exponential until you can get what you want. All right. This one's pretty. So what's one thing you notice here? Excellent. All the bases match. Generally, we have some properties that help us with shortcuts. So using what we've already learned, tell me, could I somehow put that together somehow? If it's being added, who can tell me how I can put it together? It'd be multiplied, right? We're just condensing it, okay, using what we did the other day. So if you see things, number one, the bases have to match, right? And it's the same thing like when you had properties of exponents when you were in 8th grade. You know, when you multiply powers, you add the exponents. There, the shortcut, the bases had to match in order for you to do the shortcuts. So kind of pay attention to that. Now, if the bases don't match, then you're going to have to do something else. Okay? But we can condense this. This would be the log base 2 of what? 3x. Very good. Okay. How about this one? The log base 2 of, you can say 5x minus 10, or you could do 5 times x minus 2 and then distribute. Okay? Now, based on what we learned last week, what do we know? You can cancel out these, and you can say 3x is equal to 5x minus 2, or 5x minus 10, and now you can solve. Okay? It doesn't matter which way you go. I'm going to move this over and subtract 5x. So negative 2x is equal to negative 10. So what's x? 5. It's not that hard. So you'll have to kind of use everything that we've kind of learned. Like we're putting, this is it. We're going to do some word problems on Monday, some more interest problems using logs on Monday, and kind of put that together. But as far as like solving exponentials and solving logs, we're basically, we're putting everything that we know together, and we're just trying to see what we can do to solve it. Okay? You've already looked at a problem like this. It's kind of like our interest problem, and where we were missing the time. So you've already done problems like this, so why don't you try it? Try based on what we know. What could you do with this problem to figure out t? All right. before we can do either option A or option B, because there's two different ways you can solve this, what's the first thing that has to be done no matter what you do? How do you isolate it? You've got to get this part by itself. So what do we got to get rid of? So we're going to divide by 100 on both sides. So 1.04. Now that you have the base and the exponent, option 1, somebody tell me how you solved it. Huh? Made it a log, okay? So what did you do? You said the log base 1.04 of 3 is equal to 2t. She put this in her calculator, so if you use your Math Alpha Math and you put in base 1.04 of 3, you get 28 point something. And then what is she going to do to both sides? Divide it by 2, so t would equal 14.551. Okay? That's one way to do it. How many did it that way? Okay, great. And that's perfectly fine. Who can give me option B? You put the 2t in the front and the log of 1.04 is equal to the log of 3, and then we divide by the log of 1.04 on both sides. This is how it had to be done before you had the log base button in your calculator. This is how students used to do this. So the log of 3 divided by the log of 1.04, and that gives you 28 point blah 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 blah, and you divide that by 2 and you get 14.00551. How many did it that way? And I mean, come test day, it doesn't matter which way you do. You just have to say, you know, can I take it and use my log base button? Or can I take it and take a log on either side? Okay? 10. So we're wrapping up shortly. What if you have one like this? I wouldn't, because this is a binomial. You can't just take him up because he's part of a binomial. Okay? That's what I would do. I would follow my rule of, ooh, yuck, gross, disgusting, nasty fractions. I'd multiply by, what's our common denominator? 1 plus e to the negative x. Very good. So when I do that here, those cancel and I get 50. And when I multiply it over here, I get 4 times 1 plus e to the negative x. Okay, and there's other way. You want to try to solve it from here? You can distribute. The book distributed and made this 4 and then 4e to the negative x. I divided by 4 first. Does that make sense? I got rid of them that way, and then I moved the 1 over. Isolate the e to the x, and then try to get rid of it. So let me let you think about it for just a second. It doesn't matter to me. Which one do you want to do? Do you want to divide by 4 first and get rid of that? Yes? Okay. So 4 is being multiplied, so I'm going to get rid of them first. Did anybody distribute the 4 in and then move things? That would be okay. I just want you to understand that. You should get the same thing either way. This gives you 12.5 equals 1 plus e to the negative x. And then I'm going to move the 1 over and subtract 1, so I get 11.5 equals e to the negative x. Once I have isolated it, then what can I do to both sides? I can take an ln on both sides. So this is going to become the ln of 11.5. I'm going to throw him down in front and make negative x times the ln of e. What happens to the ln of e? They cancel, and you get negative x equals the ln of 11.5, and you're going to put that in your calculator. So you get ln of 11.5. And then how do I get rid of the negative? Divide by negative 1. So x is going to equal negative 2.44235. How many were able to get that? Yes. Does everybody understand when we use an ln and when we use a log? If the base is just a number, we're going to take a log on both sides. When the base is an e, we're going to take an ln on both sides. That's just proper. Okay? All right. Two more. So what do you think? What does it look like we're going to probably try to do? Yeah, we're going to factor this like a trinomial. But the thing of it is 2x, like when you break down, normally it needs to be like x squared, does it not? So we're going to change this, and I'm just going to make this e to the x raised to the second power. Would that not be e to the 2x? Is that the same thing? And so when I square, how can I break down e to the x squared? I can break that down into e to the x times e to the x. And then one's plus, one's minus. Very good. And how am I going to get a negative 1 in the middle? A positive 2 and a negative 3. Excellent. Now what do you think we're going to do based on what we know in solving? And when we factor it, we need to set each piece equal to 0. So this is going to become e to the x is equal to negative 2. And you can solve that. I'm going to take an ln on both sides. So this will be ln, or x times the ln of e is equal to the ln of negative 2. Those will cancel. What is the ln of negative 2? It's not real because a log needs to be greater than 0. Does that make sense? You put any ln or any log and try to evaluate a log of a negative. We talked about this last week. When you try it. So this one, what do you have to do? You have to throw him out. You with me? And then you set the other piece. He's extraneous. E to the x is equal to 3. And then you can pull him down in front. X times the ln of e is equal to the ln of 3. Those will cancel, and then you can put in your calculator the ln of 3. And you get 1.09861. Any questions on? You still will have extraneous answers. All logs have to be greater than 0. All logs have to be greater than 0. So if you ever try to take a log of a negative, that's not possible. Okay? All right. Any questions about factoring? It has to be greater than 0. Right. Because I believe, like if you put in the function y equals the log, like it's going to be undefined if it's less than that. Does that make sense? You can try it. The ln of 0, it says error. Yeah, it's got to be greater than 0. Got to be greater than 0. All right. So what do you think we should do here? Nothing? Let's take out a GCF. Now, if I were you, we want to isolate what? The e. Always isolate the e to the x first. So I'm going to take out the e to the x just by himself first. Does that make sense? So e to the x, and what would I be left with? 3x squared plus x cubed, okay, equals 0. And then I'm going to factor these guys out of, like I'm going to take another GCF out. I'm going to take out a x squared, and I'd be left with 3 plus 1x, or x, equals 0. And so technically, I now have 3 factors. You with me so far? Okay, so what do you do with, we have 2 GCFs here, right? And you could have taken out e to the x and x squared at the same time. You would just have to treat them. That's 3 things being multiplied by each other. Does that make sense? This is a factor. He's being multiplied by x squared, which is being multiplied by 3 plus x. Does that make sense? You'd have to treat each of them separately. So we're going to set each piece equal to 0. So tell me about e to the x equals 0. It's not going to work. So we're going to throw him out. Okay. All right. And then x squared equals 0. So what would x equal? 0. Okay. And then here, x would equal -3. And so these are your answers. Any questions on that? Okay, so what I've tried to do is I've tried to give you, like, I could be here all day long and keep doing problems over and over and over again. Every problem is slightly different. I want you to understand that. Do y'all understand? Like, but at the same time, you just got to look and see what we can do. Okay? See if you can change it. If it's given to you in exponential form, try to take it to log. If it's given to you in logarithmic form, try to take it to exponential. If it looks like it can factor like a GCF, then that's probably what you're going to do. And based on what you already know, once you factor it, you will set each piece equal to 0 and solve it. Okay? I tried to give you some where it came out as a negative, and then it was extraneous. So that can happen. I tried to give you one with a fraction. Anytime you isolate it, and then you just try to go from exponential to log, or log to exponential, or possibly taking log on both sides. That's really your 3 options right there. Okay, exponential to log, log to exponential, or take an ln or log on each side. Isolate it and go from there. Okay, so let's try some